Welcome back to my channel. So today we'll be looking at function of a function. Okay, so let's say we have an equation or a function f of u, right? This is y is equal to f of u, but we have that u is a function of x, say h of x, right? Now f is dependent on u, but u is dependent on x. So we can write this as delta y over delta x equal to delta y over delta u multiplied by delta u all over delta x, right? If this cancels this, we'll have delta y over delta x, which is equal to the same thing on the left hand side, provided that delta u is not equal to 0 and delta x is not also equal to 0, right? So if we take the limit of this function, right? If we take the limit of this function, we have that limit as delta x approaches 0 of delta y over delta x becomes limit of this delta y over delta u divided by delta u over delta x, right? So if we open this up, we have that limit as delta x approaches 0 becomes delta y over delta u, right? Multiplied by limit as delta x approaches 0 delta u over delta x, right? Now we can also say that delta x approaches 0 and delta u also approaches 0, right? So we can say that limit as delta x approaches 0 of delta y over delta u is this limit as delta u approaches 0 of delta y over delta u, right? So simplifying further or going further, we have that limit as delta x approaches 0 of delta y over delta x becomes limit as delta u approaches 0 of delta y over delta u for this multiplied by limit as delta x approaches 0 of delta u over delta x, right? So this becomes, again, from the general principle of, or the general formula of differentiation, this can be written as this dy over dx. This can be written as this dy over du, right? And then this can be written as this du over dx, right? So our general formula is this for function of a function becomes dy over dx, right? Equal to dy over du rather, dy over du multiplied by du over dx. So this is our general formula for function of a function. Okay, so let's look at some examples. Okay, so let's say we have an equation or a function y is equal to 3x squared minus 2 raised to the power of 3, right? Now, this is a typical example of a function of a function, right? So, solving this, we can see that let u be equal to 3x squared minus 2, right? That means y will be equal to u raised to the power of 3, right? So, dy over du becomes, again, the general formula of differentiation. If we have that y is equal to x raised to the power of n, then dy over the n, d over the x rather, becomes n the power multiplied by x raised to the power of n minus 1, right? So we'll do the same thing here. So this is 3 the power multiplied by u, and then subtract 1 from the power. So this becomes 3u squared, right? But also we have that u is a function of x, okay? Function of a function. Y is dependent on u, but u is dependent on x. So differentiating u, this becomes du over dx with respect to x, okay? So it becomes 3 multiplied by 2x 2 minus 1, and then this is a constant, it becomes 0. So therefore du over the x becomes 6x, right? So now we have our du over dx, right? And then we have our dy over du. But what we are looking for is dy over dx, right? And then from the general formula of function of a function, we have that this dy over dx is equal to dy over du multiplied by du over dx, right? So let's substitute dy over du and du over dx. So this is what we'll get. Becomes dy over du is 3u squared, and then du over dx is 6x, right? But remember, from the beginning of our example, we said that let u be equal to 3x squared minus 2. So let's also substitute u in place of this. So this becomes 3 multiplied by 3x squared minus 2, and then the power 2 times 6x, right? So our dy over dx becomes 3 multiplied by 3x squared minus 2, all raised to the power of 2 times 6x, right? We can simplify this further by multiplying 6x and then 3. So our dy over dx becomes 6 times 3 is 18, and then x, then the bracket 3x squared minus 2 raised to the power of 2. So this becomes our dy over du, right? Let's also look at another example, okay? So let's say we have another function or another equation as this, as y equal to square root 1 minus 2x cube, right? So let's solve this. This is another typical example of a function of a function. Okay, so we can see that u, let u be this, right? Let u equal to 1 minus 2x raised to the power of 3. So our y becomes square root of u, right? From the laws of indices, we can simplify this to be u raised to the power of 1 over 2, right? So dy over du becomes 1 over 2, remember the power, 1 over 2 multiplied by u, and then we'll subtract 1. So this becomes 1 over 2 u raised to the power minus 1 over 2, which is 1 over 2 square root u, right? So we've gotten the y over the u. So now let's get the u over the x. Remember, u is a function of x, right? And y is a function of u, which is a function of x. So let's get our du over the x. So our du over the x becomes, now this is a constant, it becomes 0 when we differentiate, it becomes 0. And then this minus, remember the power, so it becomes 2 multiplied by 3x raised to the power of 3 minus 2. So our du over the x becomes minus 6x, 2 multiplied by 3 is 6, and then our x, and then our power becomes 2, right? So now we have our du over the x, right? And then we have our dy over du. So our dy over the x becomes, our dy over the x becomes dy over du, which is 1 over 2 square root u, and then our du over the x becomes minus this multiply, let's put the bracket 6x power 2, right? But we have that u is equal to this, right? So our dy over the x therefore becomes 1 all over 2, and then u, which is 1 minus 2x cubed, right? Multiply by minus 6x squared. And let's simplify this further, okay? This becomes minus 6x squared all over 2, 1 minus 2x power of 3. So this is our dy over the u, right? This is our dy over the u. Yeah. We can simplify this further as well. So 2 will cancel out this. 2 will cancel out 6. So we have minus 3x squared, sorry for the space, minus 3x squared all over square root 1 minus 2x cubed. So this is our dy over du.